Hello, I'm Dr. Ron England coming to you from Daytona State College, and this is part 2 of my lecture series called Beyond NoSQL. And in this one, we are going to look at serializing the classes. Actually, if we have to store the classes into a single database table structure, we have to have some way of actually creating those classes in a format that they can be stored and then retrieved back into their objects. So our requirements here are that we need to basically save the state of the class, which in this case means saving the class properties. The storage itself is dynamic storage. It's actually saved into a single table. So we have to have this ability of what we call serializing and de-serializing the objects. In other words, we should be able to convert them to something that can be stored and then converting them from whatever they're stored as back into the object using its state. And what we're really doing is we're storing them into a single database table, but they're actually being stored in a single database field. So if we look at that overview of this, you have the C# object, which is then, and the way I do it in this specific instance is I convert the properties of the object into XML properties, which are then stored into the database, and they're stored in a single field called XML data. And if you've seen the previous lectures, you know that these other fields are all simply metadata fields that allow me to find objects relatively quickly. Of course, things like their ID, because every object has an ID, I can quickly get it, but I can also pull it back on name or by the class name or other features of the object themselves. But those are metadata features. So this is kind of a review of what we've done, and the name of the field is XML data, which is where I store this, and XML property object is the name of the object which I inherit from to get all these capabilities. So how do we do XML serialization? I want to convert the object into XML, and well, first there is a built-in capability of doing XML serialization in the XML namespace of C#. However, it doesn't have all the features that I need, so I really do need to have ability to duplicate most of those features and then add my own capability to it, which is what I've done. Okay, and this is the this is a big overview of that one method that does XML serialization. It's relatively straightforward, but I'm going to kind of delve down into the details of this. So the first thing that we have to do is we take the properties of the class and we enumerate through those properties. That's what this for each is. And this is done using the namespace, the reflection namespace, which is built into C#, which allows you to look at the properties and methods of a class and actually call them and get the values. So in this case, the getTypeGetProperties returns all the properties of the object that you have. And here, all I do is I construct a string that is an XML string. And the property names are all, I don't have to worry about any special encoding of the property name because I use very straightforward names. But I do have to worry about HTML encoding the values of the property. And the important thing here is that this piece of code right here, this .getType.getProperties, returns an array of property info objects. And those property info objects contain everything I need to be able to correctly encode these things. I also put a new line break because when I look at this in a text editor, I want the XML that comes back to be easy to read. So that's that /n there. I actually have this method has a lot more complexities to it. So what I've done here is I've simplified it a bit for this lecture so you can actually understand what the steps are. Remember I called that getValue, a method called getValue, which was passed the property info. And this is really straightforward because I wanted to be able to say, okay, well first I want to make sure the property info is not null, and then I want to make sure the value of it is not null. And if that is the case, I'm just going to return back a string, which is the value inside of the XML that I had there. So in other words, that is really straightforward to get the value of the property of the class back from the property info information that I've enumerated through. And then coming back to that original method, I simply take that, and it's all converted to XML. That return value, this thing here, is simply a string of all the properties put together. Okay, so by property name for the XML, the name of the XML element, and the value is the value of the value inside of the XML element. And actually, in my more complex version, I also keep the type. Okay, in other words, the property type as an attribute in here. So if you understand the XML and you understand how XML works, you'll understand that putting together the type attribute of the XML here will be relatively straightforward to do. And it's also relatively straightforward to take a property info object, which is this, and get the type of that property info. So not terribly hard. De-serializing is just going the opposite direction. I have to be able to convert my object into XML so I can store it in the database. I also have to take it from the database and parse it back into the object itself. So what I do is I simply take the XML and I parse it into an X document, which is an actual document, is an actual object in the XML namespace. Just note that X document in the namespace is capital X, capital D. And then I enumerate through the X document and I set the properties of the class. And here's the basic of how I do this. I first take the string XML from the database. I parse it. The X document has a method, a class or a static method to do this. Then for each X element in that document, I simply set the value. The name in the X element will actually be the same as the name of the object property. That's the convention. Name of the XML element is the same as the name of the XML property, and the value that is actually put into those to the properties of the class are the value of the X element. And remember that I HTML encoded it so that it wouldn't have any problems with being true XML. And in this case, I have to decode it back. So as I go back, I decode it back to what its original format was. The set value is again relatively straightforward because it is a really built into property info. So in this case, I actually create a property info object. So the property info object is based on the property name. Remember, this is a method of the class that you are putting the values back into. So this.getTypeGetProperty will return the property. And if you can't actually do that, you can set the value of that. And it's pretty straightforward things to do too. So essentially, you're enumerating through the properties in one direction and you're enumerating through the XML elements in the other direction. And then in the final step where I actually set the value, where I pass it the property info and the value, I just make sure that the type is set correctly. That I look to see if, in other words, if I have a value, a property of my class, which is an integer, let's say, the property that is stored in the database is a string, and if the string is empty, to avoid getting an error, I have to convert it back to a value that is actually a value that's legal, and in this case, I just convert those things to 0. So for int 32, int 64, double, and single, I do this. So my final step, which is the PI, property info, set value, simply sets the value of those properties. And I put it within a try-catch because I don't want it crashing if something goes wrong or somebody's modified this or the properties have changed. Remember, we're dealing with change management, which was one of the motivating factors to do this. You may have properties that you decided to no longer exist in your class, but they may still exist in properties that you stored in the past. This will seamlessly just say, okay, well, they're still in the database, but they don't exist now anymore. We're going to ignore them, or vice versa. So it just seamlessly moves through this. So With that ability to serialize and deserialize an object, you have the ability to store the state of the object. You can store it into a database relatively straightforward. It's very easy to do. In fact, this is really, the code really just gets complex when you start dealing with more complex types of data. So the basic types are handled with the code that I just showed you with this lecture. When you start dealing with more complex types, or in other words, objects that are objects that you've created that you need to actually convert into XML, or in the case of things like dictionaries and lists and arrays, okay, you need to have that ability to handle those complex types, and you simply save those types, and then when you save the type of object you're saving as an attribute, and when you read it back in from the database, you have to have specific rules or conventions that you're going to convert it back over using, but they're relatively straightforward to handle also. So in other words, I've written methods that handle lists and dictionaries and arrays so that I can store those things into the database. And I have conventions of the way I do that. Now, this is open source, so you'll be able to see the stuff that I did, but this is really getting an understanding of how this works. So going back to that original picture of how this whole thing worked together, C# object properties converted over to XML, the state is captured, stored in the database as the XML data with the metadata to make it easy for me to actually pull those objects back. So this is part 2. In part 3, I'm going to look a little bit more about the things that I do with the database and what methods I've written so that I can retrieve objects from the database. And then step 4, which is coming up, is actually just showing an example of how I use these classes and how they save me a tremendous amount of time in the design of large-scale projects. Thank you very much, and good programming. Hopefully you're following along and enjoying these lectures. Thanks, bye.